Hi everyone, we start chapter 4, descriptive statistics and graphics. So this chapter discusses how to summarize the data set and also how to use figures to summarize the data. The most important item is empirical distribution function and the QQ plot. And the QQ plot is made based on empirical distribution function and is used to see if distribution of a variable is either normal or not. So this is very important in later chapters for regression analysis. Yeah, of course, to see if distribution is normal, we can make a histogram to see if it's normal, but the histogram and the QQ plot have the pros and the cons, so we have to study both. Okay, so at first, some tips. When you practice how to summarize data, you need some sample data sets. And this website gives a list of data sets in the default R package. You can see this website. Yeah, you have many data sets in different shape. Some data sets are just one-time series. Some data sets are data frame with several variables, and some data sets have multiple objects, maybe matrix and some key numbers and so on. So you can see the description of the data, or you can just type in our console to see what's happening. Okay, so at first we use maybe this smoke, alcohol, and esophageal cancer data. Okay, start our session. Automatically it load data package. So this data set have several, actually the 5 variables: the age group and alcohol group and the tobacco group and number of cases, number of controls. The first 3 are categorical, the other 2 are numeric. If you want to summarize this data quickly, you can type summary of this name of the data frame. Then you can see for categorical variables, the R automatically counts the number of cases for each group. We have 15 observations in age group 25 to 34 years old, and so on. For numeric variables, the R reports some descriptive statistics such as minimum, maximum, mean, first quartile, median, third quartile. First quartile means that the 25% of observations are below that number, but the other 75% are not. Okay, so next we study the histogram. Okay, so think about another example. So we generate 1,000 random numbers which follows the t-distribution with df5. This is slightly more heavy-tailed distribution than standard normal distribution. If you make a histogram, you can see that, okay, most observations are between maybe 4 to -4, but you can see some extremely small observations and extremely large observations. So this is very uncommon for a normal distribution. So you can see the difference from normal. Sometimes you want to change the size of bins. So for that purpose, we can use the breaks option. So breaks option can specify the thresholds of all bins. So if you set, this is from, actually the range is from -7 to +8. So maybe we set -8, -6, -4, -2, 0, 2, 4, 6, 8. Then if you specify breaks option, you can see the smaller, actually the wider bins. So we can use this function in this way. Okay, so now we wanna see, we wanna have the smaller bins, the narrower bins. Then, okay, maybe the good way is to use the sequence function and from minimum to maximum and by 0.5. Then the width of each bin becomes 0.5. And what's the minimum and maximum? Actually, probably negative, maybe 8 to positive 8. But okay, so I would like I would like R to do this automatically. So maybe we can use the floor function of minimum. So at first we take minimum of all random numbers and take integer, which is the smaller than the all observations. And also the ceiling function and the other way around. So we want to specify the right endpoint as an integer. So at first take maximum and we round up that number. And then b is from -7, actually -7 to +8. So using this, we can use histogram. So we have more bins. So maybe the rich line of this distribution is smoother here. Yeah. So sometimes we wanna overlay some maybe the smooth fitted line, so-called density curve on this. And for that purpose, that we can use the density function for, yeah. So we can use the density function of T distribution with df5. So basically we can use the dt function with df5. So yeah, to overlay that density function, we have to overlay with this, but at first we have to define what x we describe this. So x from maybe yeah, from the -7 to 8. So yeah, maybe yeah, we want to see some smooth curve. So maybe we will get maybe -70 to 80. Then we multiply by 0.1. Then we think about the density function of this with degrees of freedom 5. So we say this as y. So head of x is this, and the head of y is almost 0 because density is almost 0. Yeah, it looks reasonable. So we want to overlay a density curve on this. So to overlay two functions, actually we have to use the parameter argument nu is equal to t. Then we will overlay the next plot. Otherwise, the old plot disappears, the new plot appears. So this is a little counterintuitive argument, because when we do not have new graph, I mean the new pane, actually we have to specify nu is equal to true. So it sounds like that true and false are in the other way around. But anyway, so this is how R works. Then we have to specify a plot x dt. Yeah, maybe at first I discussed just, okay, so if we just overlay x and y, we see there what's the problem. Okay, so so actually it looks reasonably good, but the y-axis, actually we have different scales here. Okay, so originally we have frequency, but we put the density curve, and not necessarily the scale for y are consistent. And the scale of x, actually this one, just by chance that it works good, because both ranges from -7 to 8. But typically we have to set the range for x to get the same scale for the x axis for the two graphs. So okay, so So we renew the graph so that we set parameter nu is equal to false. Then, okay, so at first, this y-axis should be consistent. So histogram, we make this histogram as density histogram. That is, the area under the histogram is equal to 1. Because if we just put frequency on y-axis, that isn't consistent with density function. So to make it consistent, okay, so we set the y scale from 0 to 0.5, and we specify the frequency option is equal to false. Then we will make density histogram. Okay, so density histogram with the y is equal to 0 to 0.5. So this. So then now we put parameter nu is equal to t. Then we plot density function. And again, we have the same y scale. The x scale is the same because both data have range from -7 to 8. X from -7 to 8. So last time that we overwrote the x label. So maybe this time the x label, y label, we make sure that we don't overwrite anything. So empty. Then we can write this graph. Or if you want to make it as a line, this one. Okay, so this parameter nu was canceled. So parameter is equal to nu. Then we put this histogram again. Then you can see that this distribution is mostly consistent with this density curve. Probably that we should make a histogram first, otherwise the density curve, we cannot see the entire shape. Yeah, just to prepare for the next figure, just in case we type parameter nu is equal to false. Usually if we don't type, the default is false. Yeah, so this is how to make a histogram. So we studied the summary function to summarize data frame and the histogram function to see the distribution of the data.